All right. Good morning, everybody. How's everybody doing today? Good of you all to join us. I got, all right, nice. 3 people here. That's good. That's good. Nice to see that a few guys awake and all right. How's everybody doing today? Let's see. Today, by the way, so just like to hear from you guys in the comments section, in the chat section. Just say hi. I see a couple people here that I know. Hi Anna. Hi Lupita. And anybody else, just say hi. And if you have any questions, tell me right here. And just a reminder, so we got a test coming up. Test is going to be either next Tuesday or Wednesday. I was going to shoot for next Tuesday. If you guys want to do it Wednesday, it doesn't really matter. If we do it Wednesday or Tuesday, I mean the other day, we're just not going to do anything. I'm just going to have a break day, okay? So that's entirely up to you which day you guys prefer, Tuesday or Wednesday. And we're going to finish up. I do actually, forgot to mention, I do want to talk about one slightly new thing today and review the whole concept of conjugate acids and conjugate bases. We are going to talk a little bit about buffers today, not in any real detail, but just the basic concept of what a buffer is. And so we're going to talk about a buffer today. And we are going to talk and solve a couple titration problems together, talk about this acid-base neutralization, and then you guys have some review problems that I put up. Hopefully you guys all found the review problems that I put up this morning. If you checked yesterday, they were not up, but I put them up this morning. All right, so let's see. How is everybody doing? Okay, so if you guys have any questions, anything you guys want me to go over, tell me. I do want to go over this homework here. So hopefully you guys all turn in your homework, but we are going to look at this one first and see what do these acid-base neutralization reactions look like. Now, there are other possibilities, but I just want to look at what's known as complete neutralization. So we're going to remove all of the H's or all of the OH's in an acid or a base. Okay, so without further ado, let's get started on this one right here. We have, this is hydrobromic acid and lithium hydroxide. So right away we can recognize, okay, this is our acid, this is our base. But let's go ahead and do the neutralization first. So anytime you have, excuse me, your H plus and your OH minus, the H plus and the OH minus are going to come together and we're going to get H2O. So your fundamental acid-base neutralization reaction looks like this. H plus, your acid, plus OH minus, your base, is going to make H2O. Okay? So we're looking for that in all of these. And we have just one of them because we have one H plus and one OH minus, which means what do you have left over? You have lithium and bromide, the Li plus and Br minus. Because lithium is plus, we're going to put that in front. So it's going to be LiBr, like that. Okay? And it's already balanced. There's no 2's anywhere in this reaction, so we're good to go. Do want to mention, well, what is what here? We said the one with the H is going to be the acid, but we can even look a little bit closer and see HBr. What's happening to HBr? It is losing the H because here it turns into lithium bromide. It turns into Br without an H. So this is going to be our acid, and this over here is going to be our conjugate base. Okay? Lithium hydroxide is going to be your base. That's your OH minus. And what's the OH minus doing? Is gaining an H plus. And so when it gains the H plus, it turns into your conjugate acid. Okay? I probably should have, I think this is going to be kind of repetitive. I probably should have flipped these back and forth just to see if you guys could do it. But apparently I put all of the first ones are acids and all of the second ones are bases. So we're going to have all of these are conjugate acids and all of these are conjugate bases. So I'm not going to bother to rewrite them all because I just kept the order the same. But in theory, I could have literally just flipped these two. I could write the base first if I wanted. So sorry about that. I didn't give you guys any variety in this homework. You guys really should be able to deal with if I put the base first and recognizing, oh, that's the base. Okay? But anyway, let's go ahead and write these, because the real main thing that we're looking at here is how do we draw this neutralization reaction? Okay, so we have H2SO4, we have the 2 H pluses. Notice that 2 there. That means we have 2 H pluses, and we have 2 hydroxides, right? Barium hydroxide has a 2 there. So in this case, we're going to make 2 H2O from 2 hydroxides and 2 H pluses. And that's going to leave us with barium 2 plus and sulfate 2 minus. And because it's 2 and 2, and you guys should be thinking about this, think about, okay, that's Ba2 plus, sulfate's SO4 2 minus. The 2 and 2, you'd think they would just switch. It would be Ba2 SO4 2, but because they have the same charge, it's just going to be simply BaSO4. And that's it. That's your full equation. Okay? All right. Next up, we have H3PO4 and potassium hydroxide. This is phosphoric acid, and this is potassium hydroxide. Now notice here we have 3 here in front, after the H. So we have 3 H pluses and only 1 hydroxide. So we need to balance that somehow. To balance those 3 H pluses, we're going to need a 3 here in front of the potassium hydroxide. That's going to get us 3 hydroxides for every 1 phosphoric acid. When they react, the 3 H pluses and 3 OH minuses are going to make 3 H2O. And you're welcome to balance this at the end. That works fine too, but I just like to balance it as I go. As we do this, we're finally going to get 3 K pluses left over and a PO4, right? So K is K plus and PO4 is PO4 3 minus. And that's going to get us K3PO4. Notice that we have H3PO4 here, and that turns into K3PO4 because, okay, are we back? I think we're back. I just love technical issues. It's just the best part of this whole situation. And the thing is, I have wonderful internet here, and what's happening, I still think it's a problem with YouTube itself. YouTube is just getting overrun because there's so many people online right now. Anyway, whatever the issue is, it's just happening to me on a daily basis now. So here we go. Last thing, we have perchloric acid and we have aluminum hydroxide. Right? Perchloric acid, aluminum hydroxide. We got the same kind of situation going on as the previous one, only this time we have 3 hydroxides and only 1 H. So if we have 3 hydroxides and we want to neutralize all 3 of those hydroxides, I'm going to put in 3 of our acids, 3 of our perchloric acids to fully react with that aluminum hydroxide. That's going to get us, once again, 3 H2Os. And our final product is going to be, well, aluminum has that 3 plus charge and our perchlorate is 1 minus. We haven't really dealt with perchlorate very much, but we can notice that it has a 1 minus charge because you have only 1 H right there. And so also we notice we have a 3 in front, so we need to have 3 of these in our balanced reaction. And we have only 1 aluminum, so 4, 3. Okay, I didn't write that very well. So AlClO4, 3. Okay, so that's what's going on here. You have 3 hydrogens and 3 hydroxides to make water. You have 3 perchlorates, and you have 1 aluminum, 1 aluminum. So that's your balanced reaction. Okay? All right. Any questions, guys? Any questions at all? No questions? All right. North's Best Fisherman. That's an interesting name. Cool. I guess you fish. That's good. I like to fish. Now, we are going to go on. Hopefully that doesn't offend anybody. All right. And we are going to go on. We're going to do the second page of that if I can find it. Where is the second page? Sorry. I am looking for. Here we go. Second page. We have 2 titrations problems. Oh, that's Shelton. All right. You love fishing. Awesome. maybe you can teach me some fishing stuff because I am not very good at fishing. And do you do mostly like saltwater fishing or freshwater fishing? Here we are. All right, we're gonna do numbers 3 and 4. We're gonna do titration there, and let's get started here. So suppose you titrate an unknown acid with a known base. And remember, the whole idea of this titration is that we are going to try to figure out the amount or the molar mass of an unknown that we have using a known that we know everything about. We know the molarity of this, and we know the amount of stuff that we add, okay? And all we're doing is an acid-base neutralization reaction. We are reacting this acid with a base to totally neutralize it, and when they're neutralized, you have a color change, right? Saltwater fishing and freshwater. Awesome, a learner. Here we go. But when it comes to chemistry, I am the master, and you are the learner. So we can trade. Here we go. So let's see. What are we doing? We have a amount of base, and what we're going to do is we're going to recognize that when we get to that equivalence point, which is when the color changes or when the pH meter changes the pH very, very quickly, then we're going to stop, and that's when you have an equal amount of acid and base. So let's see. This amount, this number here, we're going to use at the end. What we're going to do is we're going to use this volume here, and so we're basically trying to calculate N. So kind of the steps are, first we're going to calculate N, and we calculate N because we have the equation M equals N over V, and we multiply both sides of the equation by V. That's going to get us N equals Vm, so N equals Vm, and we can also think of molarity as a conversion factor between volume and moles, okay? After we do that, then we're going to calculate the molar mass, and the molar mass is going to be the mass over the moles, okay? So let's do this calculation. The volume must be in liters. So we have 21.3 milliliters. So the volume must be in liters because these here are moles per liter. So we're going to convert that to liters right away by moving that decimal point 3 spots to the left. 1, 2, 3. So it's going to be 0.0213 liters. Our molarity is going to be 0.225 moles per liter. Notice that our liters over liters are going to cancel out, and we're going to be left with moles as our answer for that. And so I'm going to type in 0.0213 times 0.225 to get us 0.0048, okay? 0.00479 moles. Now, remember, that is moles of our known sodium hydroxide that we add, but is also equal to the moles of the unknown acid. That's the beauty of titration. That's what this whole titration is doing. The titration is saying we have a known amount of this known material. Well, how much of the unknown do we have? And it's going to be the same amount. So finally, we're going to take that unknown mass, 1.345 grams, and divide by moles, 0.00479 moles, and that's going to get us a molar mass. So 1.345 divided by our previous answer, and I'd make sure I divide by the previous answer so I don't have any kind of rounding issues in my calculator. And that's our final answer. It's going to be 280. Technically, yeah, we have 3 significant figures, so I'm going to round this 0.6 up to 1, so it's going to be 281 grams per mole. Okay? Questions on that? Questions on that? All right. So if there's no questions on number 3, let's jump into number 4. Okay, so if you wrote 280.79, that is okay. I would prefer you guys to stick with the correct number of significant figures, so just round it up to 281. And if you write 280, not a big deal. So if you have 280, 281, or 280.6 or 280.7, that's fine. But try to not round these numbers, but do round your final answer, okay? So I'm not gonna be picky about significant figures, but I still want you guys to do your best to have the correct number of significant figures, and that's, in this case, is gonna be 3, okay? All right, number 4. So if you titrate, suppose you titrate an unknown base this time with a certain amount of acid. This is nitric acid, and you're going to dissolve 0.633 grams. So we're going to take this number and use it at the end, and it's going to require 76.8 milliliters of this. And so what we're going to do first of all is we're going to calculate N once again. We're going to start off and we're going to say, okay, N equals our VM, right? So it's going to be this volume here, and I'm going to take it and move the decimal point 1, 2, 3 spots to the left. So that's going to be 0.0768 liters, right? And multiply by the molarity, which is 0.0888 moles per liter. And that's going to give me the number of moles of acid that I added. So let's see, 0.0768 times 0.0888, 0.00682, 0.00682 moles. And once again, that's the moles of our acid, our nitric acid, and is also the moles of the unknown. That's the beauty of titration. Moles of acid equal the moles of base. Let me even write that down here, right? Moles of acid equal moles of base, because we're doing an acid-base neutralization reaction. So those two things are the same. So our unknown is equal to the known in terms of the number of moles. Finally, let's calculate the molar mass. The molar mass is going to be the mass of the unknown divided by your moles. So that's going to be 0.633 grams divided by 0.00682 moles. And I'm going to use that number I have in my calculator and just say I have 0.633 divided by that. It's a very good habit to always just use the previous answer or to store numbers in your calculator. And our final answer here is 92.8. I do think we have 3 sig figs, so it should be 92.8 grams per mole. All right, that's it for the homework. Okay? Any questions? Any questions at all from the homework? And I can say right now, for your test, you will have one problem like this. It'll be either like number 3 or like number 4, which are basically the same kind of problem. It's just one's for an acid, one's for a base. So there's, in terms of the calculation, it's done really the same way. So you have one problem like that for your response. You have one problem like we did before. I forget. Let me see if I can find it here. pH review. You're going to have one problem, like this from the previous homework, where it's either number 4 or number 5, where you're calculating the pH of an acid or a base, and you have to do this whole process of calculating the moles, then calculating the molarity, and then finally calculating the pH. So this whole 3-step process, you're going to have one of those kind of problems, and you're going to have a bunch of other smaller problems. But those two are going to be your big problems on the test. Okay? So we're expecting a test, and you guys feel free to give me some feedback here. We can do the test Tuesday or Wednesday. It's going to make 0 difference to me. I don't care whether it's Tuesday or Wednesday. I have it in the calendar as Tuesday, but we can push it back to Wednesday if you want, just to give you an extra day. But maybe what really depends on what else you have that day. If Tuesday is a busy day, you can move it to Wednesday. But if Wednesday is a busy day, Tuesday would be the best. So depending on you guys, but you are going to have to wake up on time. So the test is going to start right at 10:10 or 10:15, whatever, and I'll give you guys the full class period to do that. Okay? So feel free to comment here. You guys are actually showing up to class, so what do you guys think? Just write down in the comments, or if you don't care, just say, I don't care. And that's cool. So if you don't care, we'll probably just make it Tuesday. But if you want it to be Wednesday, just tell me. All right. So I did upload a new homework of, it's got some review questions. So the review questions, so number 3 is kind of review, but not really. But the review questions really start with number 6, and then the whole back page is going to be review. So we're going to go through all these review questions next time. Today, I do want to talk about buffers and just talk about buffers in general. Now, we're not going to get into really a whole lot of details. So buffers can be complicated, but don't worry, we're not going to get into the complicated nature of buffers. Okay, we're just going to talk about, what is a buffer and why do we care and how do you make a buffer, and that's about it. Okay, so what is a buffer? A buffer is going to be something, a chemical, right, that when you add it to a solution or add it to something that is going to resist a change in pH. Okay? So basically a buffer helps to keep a fairly constant pH, which is good for a lot of different things. You guys have a buffer in your blood, right? Your whole blood, actually you have 2 different buffer systems in your blood. So that helps, like if you get exposed to a certain amount of acid or a certain amount of base, let's say you eat something bad or you breathe in a certain amount of acid in the air, it's not going to affect you too much because you have a buffer system in your blood. Unless, of course, you get exposed to a whole lot, then your body can't handle it. But you have a buffer system in your blood that helps your blood to keep a constant pH, to keep you healthy, okay? You can also imagine buffers are going to be in various different food products to keep a constant pH. They might be in certain different medicines. For example, aspirin is oftentimes buffered. You might have buffered aspirin so that it's not too acidic, okay? And so adding buffers to different things basically helps to keep a fairly constant pH, okay? All right. So how do you make a buffer? A buffer is, how do you make it? Make a buffer by having a weak acid and its conjugate base, or a weak base and its conjugate acid. Okay, it has to be the conjugate base of that acid. It has to be the conjugate acid of that base. But the key here, the other key term here is weak. And that's something that we haven't really talked much about. I think I've kind of used the term strong and weak before, but I haven't really explained what the difference is. Everything, or most things that we've been talking about so far before, have been strong acids and bases. And so what's the difference? The difference is that a strong, and bases are essentially the same thing. So a strong acid or a base will, completely dissociate or completely ionize. Okay? Whereas a weak acid will only partially ionize. Well, what does that mean? That means that when you put in, let's say a strong, let's give you a couple examples here. A strong acid, HCl, when you put that into water, it's going to make completely turn into 100% H plus and Cl minus. Okay? But if you have a weak acid such as acetic acid, so acetic acid, that's vinegar. Okay? So that's going to be H, and then C, what is this? C3, H, hold up. No, it's C2. I'm forgetting. What is acetic acid? I have to draw it out to see. So acetic acid, OOH, CH3. So we have, sorry, this is going to be HC2H3O2. So that's acetic acid. When you dissolve that in water, it's going to make only a little bit of H plus and acetate, right? So you're going to have a little bit, a very small amount of this H plus and our C2H3O2 minus. Only a small amount. Most of that is going to be in the form of the original acid. It's only going to partially ionize. That's what a weak acid is. Now, don't worry, you guys don't need to be able to recognize a weak acid. You don't need to memorize which ones are strong, which ones are weak. I will tell you, okay? I will tell you. You don't need to worry about that part, okay? So I just want to give you guys this as a reference. So weak acid will only partially ionize, all right? So when we, let's go through number 3, part of number 3, and then we'll talk about number 4 and 5. So 4 and 5 are basically saying, okay, we have, oh, look at this. I even have the formula for acetic acid down here. Brilliant. Okay, so you have a weak acid or a weak base. How could you make a buffer from it? The simple answer is by adding the conjugate base of this, or by adding the conjugate acid of that. And we're going to get down to that here in a second. I want to first do number 3. Okay. So, conjugate acids and conjugate bases, we've talked about them before in terms of a chemical reaction and identifying a conjugate acid and a conjugate base in a chemical reaction. Sarah, you're not sure if I'm getting your emails. I'm not. I don't think I got your emails. But then again, I am getting a whole lot of emails, so maybe they got lost. So try again. Try to send me an email again. I don't know what's going on. Maybe they got put into my spam folder. Are you sending it from your school email? If you're sending from your school email, it should be no problem. But if you're sending from like an outside email address, it might sometimes get sent to the spam folder, which I could check. But send me an email again, or make a comment on Google Classroom, and we'll try to work that out. All right. So basically, what is a conjugate acid? A conjugate acid is the base after it has gained, the conjugate acid is the base after it has gained an H+. The conjugate base is an acid after it has lost H+, okay? And so we've identified those things in a reaction, but I also want us to look at, if you have an individual chemical, okay, what is the conjugate acid or what is the conjugate base of that, okay? And so just looking at an individual chemical, H2O can act as an acid or a base, okay? And so if it acts as a base, that means it's going to accept an H+ and turn into its conjugate acid. And so its conjugate acid is H3O+, okay? So in general, a conjugate acid is simply this chemical plus H+. But water can also act as an acid sometimes. If you react water with a base, water will react as an acid. And so you can go from water to its conjugate base. And so in order to do that, you would take away an H+, and that is, let's change the color here, and that would be OH-. Okay? Notice that going from the chemical to the conjugate acid, the charge increases by 1, and going from the chemical to the conjugate base, the charge decreases by 1. Okay? Notice that going from the chemical to the conjugate acid, you add an H. Going from the chemical to the conjugate base, you remove an H. Okay? So, very important. Let's go through a couple of these, and I'll let you guys do the rest for homework. Okay? So let's just do 2 more, and I'll let you guys do the other ones. All right, so NH3. So NH3, when it gains an H+, it's going to turn into NH4+. That's the conjugate acid of this. Okay? When it turns into its conjugate base, it's going to lose an H+, and so that will be NH2. Well, what's the charge going to be? It's going to lose an H+, the charge is going to be negative, so it's NH2 minus. Okay? Let's skip down to the last one. You guys can work on these two for homework. Let's skip down to the last one and see, okay, what do we do with this charge here? Okay? So the conjugate acid of CO3 2 minus is we add an H+. Okay? And if we add an H+, it's going to be HCO3. What's the charge going to be? It's going to be 1 minus, because you're adding H+, that's going to be HCO3 1 minus. Okay? How come the first one isn't a negative? The first one. Which one do you mean by the first one? Which one is the first one? You mean the F. How come the F isn't a negative? It is. Oh, right here it is. It's just maybe you can't see it. So HF. Okay, so HF, it's kind of small here. I'm writing bigger than I typed here. So this is HF. This is just a chemical, hydrofluoric acid or hydrogen fluoride, HF. When you add an H+, it's going to be H2F+. When you remove an H+, it's going to be F-. So that is F-. Okay, F-. That's what that is. Okay? So maybe you just couldn't see that minus. It's kind of small. It's really, really small. Yeah, so that's F- there. All right, so last one here. The conjugate acid of this thing is we add an H+, so it's going to be HCO3-. Really tricky here, though. You need to keep in mind, if it starts at 2-, you're going to add 1 to the charge, so it's going to be HCO3 1-. Okay? Now, even trickier, what's the conjugate base of that? Well, the conjugate base is when we remove an H+, but if there's no H, there's no possible way we can remove an H. So then we just say none. Okay? There is no conjugate base of this because this cannot possibly act as an acid because there's no H there. Okay? All right. So that's that. You guys can do these two. We'll go over these two for on Monday as a review. So let's jump down to numbers 4 and 5 and talk about those, and then we're done for the day. Okay? So we have acetic acid, HC2H3O2 is a weak acid. How could we make a buffer from it? The simple answer is by adding if it's a weak acid, all we need to do is add its conjugate base. But I want you to know what its conjugate base is, right? Its conjugate base is, okay, we're going to take away that H. And so the conjugate base, so we can add C2H3O2 minus. Okay? And that's what I want you to write down. We're going to add the conjugate base, we're going to add C2H3O2 minus. Or you could say, and now this is a step further which you don't need to know, okay, because this doesn't exist all by itself. It has to have some sort of counter ion with it. You could say we're going to add sodium acetate, which would be NaC2H3O2 or something like that, okay? But the answer that I'm mostly looking for you guys to think about is this, okay? So add that conjugate base. That's the conjugate base. So let's do number 5 together. You know what? Actually, I'm going to leave that as homework. I want you guys to think about that. Okay, so this is a weak base. How could you make a buffer from it? You guys think about that. And let's just end class there. Okay, so any questions before I sign off? Any questions at all? Okay, Sarah, I'm going to email you, and then if I don't get your email, I'm going to email you. We'll see what's going on. Okay. And hopefully we get that figured out. We do have 1 vote for Wednesday. Sarah said Wednesday, and I have 0 votes for Tuesday. So we have a 1-0. And so hopefully we can get some more people to vote in here. Oh, and we have Lupita says, I can't read that. I don't even know how to pronounce it. Mirtzoles. What does that actually mean? I'm thinking that might mean Wednesday, but that's a real guess. Okay, so both pages are due on Monday, not tomorrow. Tomorrow is Saturday, right? Both pages are due on Monday. And Lupita says, yes, Wednesday. Okay, so Wednesday. So Lupita wants, so we have 2 votes for Wednesday, no votes for Tuesday. So right now it's looking like probably Wednesday, unless we have people that actually care and say they want Tuesday. Okay. So yeah. So, all right. So we have both pages. The other things, these are all review questions. So number 6, 7 through 13, they're all review questions for you guys. You guys should be able to do them. I know we haven't talked about number 6 for a long time, but that's a review type question, and all these things. So monoprotic, diprotic, triprotic. So go through those things. Oh, and there's one more thing. So amphoteric. Yeah, so review is all from 6 to 13, but I want you guys to do that for Monday because I'm going to talk about it on Monday. So do the whole thing. The whole thing is due on Monday. Please go through all the problems on Monday for Monday, okay? And one last thing, which I really forgot to mention, is this, and that's the term amphoteric. Make sure you know that for the test too. Amphoteric basically means something can act as an acid or a base. So just a vocab term that you guys should know. Yeah, okay? And so we notice that, oh, look at this. Water is acting as an acid or a base, and so it can act as an acid or a base. NH3 is amphoteric. So both of these chemicals are amphoteric. All right, anyway, so I'm just going to close out there, and we're all done for today. Have a great rest of your day. See you guys, and also have a great weekend.